And this time, instead of trying to target this sort of certificate vulnerability that's exposed, we're just going to take advantage of the architecture of these products. And by that I mean all the application whitelisting products I tested use kernel level drivers in order to implement their functionality. And there's a really good reason for that. Like, kernel level drivers allow you to basically monitor everything that's going on the computer, on the file system, or in the registry. So it's a really easy point for them to be running at. They can see everything they need to see to implement their sort of security functionality. The other good thing about it is that they can modify the results of those commands. So for instance, fake malware.exe, which you have normal permissions to if that product weren't in place, isn't able to run, because when you go to launch it, it says, the filter driver says, I don't want this to run, so it gives it an access denied error. So what we're going to do here is we're going to take advantage of the fact that it needs this kernel level driver to perform its function in order to block something. And we're going to slip another kernel level driver directly underneath it so that that driver loads before the application whitelisting products driver is ever loaded, so that you essentially gain all of the control it had over it. So the way we're going to do that is we're going to insert this, we're going to install this driver from within the account. Now, many of you may be aware already that Windows 7 doesn't allow you to use an unsigned driver on a computer. Now, there's some pretty smart people who have managed to exploit this and have found ways to get around it. I opted for something a little more elegant. I took an existing driver called callback filter. And this is a driver that exists and is sold by another company so that you can gain access to that kernel level code without having to write these dangerous drivers yourself. The problem is I can use that to implement my malicious desires with it, and because it's a legitimate signed driver, Windows is going to allow it. So the first thing I'm going to do for this is simply move the driver into, I'm not going to double click on it. I'm going to move the driver into the drivers folder. I'm going to install a registry key that basically puts the service in place on the computer. So that's allowed to go. And then for drivers, you have to also add this enumeration root registry key that Microsoft, as you'll see, protects. So if I try to add this on its own, it tells me I can't do it. The intention is to prevent you from being able to install these without going through their mechanism. Unfortunately, Microsoft didn't implement it in the most sophisticated manner. So if you simply go to permissions on that particular key, claim ownership of that particular key, then allow permissions for everyone on that particular key, now all of a sudden that area that you weren't able to edit before for very important security reasons is something that has been trivially bypassed. So what I'm going to do with this particular filter level driver, I'm going to enact some bad behavior. And in this case, I just want to deny access to a particular README file. So I have these two READMEs on the desktop. One of them is the README for demo.txt. For now, you're going to be able to see this. But once we enact the kernel level driver, it's not going to work anymore. And then we have this other one for a control that you're going to be able to see forever, because I'm not preventing that one from being launched. So we're going to add a registry key that basically says, I want to put this in place. I want to block this text file from being launched. It's just a capability that's offered by callback filter. So the next thing we need to do, we installed it, but we haven't actually loaded it into memory yet. So we use Microsoft's own loading mechanism to try to load it. And what you're going to see is it's going to tell you you can't. Access is denied. And the reason for that is because the application whitelisting process is running currently. So it sees this driver that it knows isn't allowed to launch, and it's not going to allow it to launch. The problem is because this driver loads at a lower level than the application whitelisting one, once we restart it, that no longer is the case. So we're going to reboot now, and what we're going to see is that our driver that we installed now comes in underneath the application whitelisting product and is able to run. And from that position, it's capable of doing lots of malicious things. It can monitor any file system activity. It can monitor any registry activity on the computer, which basically gives it a free run of any sort of sensitive information you have present on there, any debugging capabilities, things of that variety. It can, it can use network commands in order to send out the information it gathers. Or if it wants to be particularly malicious, it can actually hide things that are going on that system and enable rootkit-like capabilities. So the first thing I'll show you is that the application whitelisting product is still running. I still can't launch this fake malware.exe. And then I'll try to load that driver again. So we go to load it. But this time it says an instance of this service is already running. And that's because this driver has already managed to load itself into memory, even though this application whitelisting product is working without any sort of issues. So to prove that it's actually running, we'll look at the control text file. You can still read it as normal. But all of a sudden, when you just want to read a normal text file named readme for demo.txt, access is denied on it. So in this particular case, I did something that was not especially malicious, but if I wanted to, I could use it to hide EXEs that are present that are actually enabling malicious activities to take place on the computer. And once you have that driver in place, you've now managed to gain full control over the computer for any sort of espionage or malicious purpose. So, were there any questions around this particular exploit? Yes.
Yeah, just curious where you ran across that one driver, that callback driver.
I actually searched for it. So there's more than a few of them. Because the problem with the kernel level driver is if you have any sort of error in the code, it blue screens your computer, which means writing them on your own is a really risky proposition. So in order to simplify that, there's a few companies out there who provide these sort of capabilities to legitimate developers so that they don't have to develop drivers themselves. The problem is malicious developers also have access to these, usually don't pay for them, so there's not a trail for it, and they're still capable of implementing these sort of technologies and techniques. Were there any other questions? Okay, so that concludes the exciting demo portion of our talk.